Hi, I'm Mindy from Apex Tutoring. Today we'll be working through the 2022 HSC Mathematics Extension 1 exam. I'll be assisted by the brand new Casio FX8200AU. Let's get started. Question 1. It is given that cosine of 23 pi over 12 is equal to root 6 plus root 2 all over 4. Which of the following is the value of cosine inverse of the square root of 6 plus 2 all over 4? So it's important to remember what the range of cosine inverse is. In order for the inverse of cosine to be invertible, we have to restrict the domain of cosine from 0 to pi. That means the range of cosine inverse will only produce values from 0 to pi. That means we're going to be looking in quadrants 1 and 2. Now, where is 23 pi over 12? 23 pi over 12 is just short of being 2 pi. So that would be in quadrant 4. We just need to find an angle in quadrants 1 or 2 for which cosine would be equivalent to cosine of 23 pi over 12. Now, we know cosine is positive in quadrant 4 and of course in quadrant 1. So we need the same angle in quadrant 1. Now, of course, the angle formed here, if we had a right triangle, and the angle with the x-axis would be pi over 12. So we're looking for that same angle in quadrant 1, which is simply pi over 12. So cosine inverse of root 6 plus root 2 all over 4 would be equal to pi over 12. The answer is C. Question 2. The graph of f of x equals 3 over x minus 1 plus 2 is shown. The graph of f of x was transformed to get the graph of g of x as shown. What transformation was applied? Now, our options include f of the absolute value of x, the square root of f of x, f of negative x, and 1 over f of x. Let's take a look at the two graphs again. So one of the easier transformations to spot is 1 over f of x. And that's because whenever f of x is 0, 1 over f of x will have a vertical asymptote. So let's take a look. There's only one place where f of x is 0, and that's here, between what appears to be negative 1 and 0. Now, if you look at g of x, it does not have a vertical asymptote at that value of x. It actually has one at negative 1. So that's not the transformation. Another easier transform to pick up on is the square root of f of x. And that's because you can't square root negative numbers. And so anytime f of x is negative, that part of the graph will disappear in g of x. As you can see, g of x has some negative values. That would not be possible with the square root of f of x. So we know we can cross that one off the list as well. Now, f of negative x is simply a horizontal reflection, which is going across the y-axis. The graph we have, g of x, is definitely not just the reflection of f of x over the y-axis. So we know it's not that one either. That just leaves f of the absolute value of x. Why is that one the right answer? Well, when you take f of the absolute value of x, what happens every time you plug in a negative value of x is it gets changed to a positive before the function is evaluated. So the graph to the left of the y-axis gets deleted. We can still plug in negatives, it's just that now they produce the same outputs as the positives of those numbers. And so what happens is then the part of the graph to the right of the y-axis gets copied and reflected onto the left side of the y-axis. And you can see that's what happens going from f of x to g of x in this question. So if you take this graph here and then reflect it, and the asymptote as well, and that's why we had an asymptote at negative 1, it's the reflection of the asymptote at positive 1, and then we're reflecting this hyperbolic type of shape here, which produces, of course, g of x. So the correct answer is A. Question 3. Let p of x be a polynomial of degree 5. When p of x is divided by the polynomial q of x, the remainder is 2x plus 5. Which of the following is true about the degree of q? So, when a polynomial is divided and we have a remainder, the remainder cannot be of equal or higher degree to the divisor. In this case, the divisor is q of x. So, the degree has to be less than the degree of the divisor. Now, the remainder is a linear expression, and so the degree of the remainder is 1. So the degree of q of x has to be bigger than 1. It doesn't have to be 2, but it could be 2. So the answer is D. Question 4. The diagram shows the graph of the sum of the functions f of x and g of x. Which of the following best represents the graphs of both f of x and g of x? So here are our options. Let's look at the graph of the sum. When summing two functions, the sum will be 0 when the graphs are simultaneously 0 or equally distant from the x-axis. So let's see which of these graphs would produce zeros at approximately these locations, here and here. Option A looks like it could be a reasonable choice because at those approximate values of x, the two graphs are about the same distance from the x-axis. If we check the other graphs, we'll see what happens. So in option B, the line graph is higher above the x-axis at both points than the parabolic graph. And the graphs in option C do not appear to be equally distant from the x-axis at those points. And neither do the graphs in option D. So A is the correct answer. Question 5. A curve is defined in parametric form by x equals 2 plus t and y equals 3 minus 2t squared for -1 less than or equal to t less than or equal to 0. Which diagram best represents this curve? Okay, so x is linear, while y is quadratic. So the points horizontally should progress in a linear fashion. However, the y-coordinates of those points would form a parabolic shape. Let's take a closer look at y. Notice how in terms of t, it's a downwards facing parabola. And also in terms of t, its maximum would occur at t equals 0. So the correct answer should be B. However, you can also try doing a quick table of values to see how the points change as t goes from -1 to 0. When t is -1, x would be 1 and y would be 1, as we know. At -0.5, x would be 1.5 and y would be 2.5. And at 0, x will be 2 and y will be 3, as we know. You can see that y grows more quickly between -1 and -0.5, and then more slowly from -0.5 to 0, which would help confirm the shape of the graph being that concave down shape that we see in option B. So B is the correct answer. Question 6. The diagram shows the vector u and the vectors I plus j, -I plus j, -I minus j, and I minus j. Which statement regarding this diagram could be true? The options all involve the projection of u onto one of these vectors. So let's take a look at each of the options. Option A is the projection of u onto I plus j is the vector 1.1i plus 1.8j. So what would the projection of u onto I plus j look like? I'll extend I plus j and draw a line from the end of u perpendicularly to the I plus j line. The projection would be this vector here. You can see that that vector is a little longer than I plus j, but both the horizontal and vertical components are extended approximately the same. So I would rule option A out. Option B is the projection of u onto negative I plus j is the vector negative 0.4i plus 0.4j. So what would that projection look like? So I'm going to draw a line from the end of u perpendicularly to negative I plus j. So the projection would be this vector. You can see that this vector is much shorter than minus I plus j, and that again both components are shortened about the same amount. Also, in this option, the signs remain correct as the direction of the vector hasn't changed. So we might be considering option B as the answer. Let's check the other options. So option C is the projection of u onto minus I minus j is the vector 3.2i plus 3.2j. So what would that projection look like? Well, that projection would be the first one we looked at, this one here. So that's going now in the opposite direction of minus I minus j, and it is longer than minus I minus j. But is it 3.2 times longer? It doesn't seem so. So we'll probably rule out option C. Now option D says the projection of u onto I minus j is the vector 0.5i minus 0.5j. What would that projection look like? Well, it would be the second one we drew. It would be this one here, going in the opposite direction of I minus j. So if the direction has been reversed, then the I and j components should be of opposite signs. But here, both components remain the same sign, so we should rule out D as well. That confirms what we thought, that the correct answer is option B. Question 7. The diagram shows triangle ABC, with points chosen on each of the sides. On side AB, 3 points are chosen. On side AC, 4 points are chosen. On side BC, 5 points are chosen. How many triangles can be formed using the chosen points as vertices? Okay, let's first consider triangles that have vertices on 3 different lines. For example, this triangle here. How many different ways can we do that? Well, from AB, we have 3 vertices to choose from. On AC, there's 4, and BC, there's 5. So that's 60 triangles. Next, let's consider triangles formed by picking 2 vertices first from the same side, such as these 2 here. Now, first of all, if I pick 2 sides on BC, how many different ways are there to do that? There's 4 ways to pick them that are next to each other, 3 ways to pick them, so they're 2 apart, 2 ways where they're 3 apart, and of course 1 way where they're 4 apart. And then when we pick the 2 vertices on BC, then there are 7 points totaling on AB and AC that the other vertex can connect to. So we'll times that by 7. So that's 70 triangles. We can do something similar from AB, where we have 2 choices for vertices next to each other, and 1 choice for vertices that are 2 apart. And then there's a total of 9 vertices for the third one to connect to. 27 triangles. Then if we pick 2 vertices on AC, there's 3 choices that are 1 apart, 2 choices 2 apart, 1 choice 3 apart. And then on the other 2 lines, we have 8 vertices the third one can connect to. So we'll times by 8. 48 triangles. So altogether, 205 possible rectangles. The answer is C. Question 8. The angle between two unit vectors, A and B, is theta, and the length of A plus B is less than 1. Which of the following best describes the possible range of values of theta? Okay, let's draw a diagram to help work this one out. I've drawn a unit circle since we're dealing with unit vectors. Let's draw two unit vectors and their sum. The green vector would be the sum of the two red vectors, but we want the length of their sum to be less than 1. Well, that means we need to change the angle between the two vectors, make it wider so that the green vector, their sum, comes inside of the circle. So how wide would we need to make the angle between the two vectors? Let's start with their sum equaling 1, which means it's on the unit circle. If that's the case, then each of the vectors with the sum forms an equilateral triangle, which means the angles between each vector and the sum is 60 degrees, meaning the angle between the two vectors is 120, which is 2 pi over 3. Now, the sum needs to be less than 1, so anything larger than 2 pi over 3 would be sufficient. What's the biggest angle that can be between the two vectors? Well, that will be 180, or pi. At that point, the two vectors would be in a straight line, and their sum would equal 0, which is less than 1, and we can include that angle pi. So that means the answer is D. Question 9. A given function, f of x, has an inverse, f inverse of x. The derivatives of f of x and f inverse of x exist for all real numbers x. The graphs y equals f of x and y equals f inverse of x have at least one point of intersection. Which statement is true for all points of intersection of these graphs? Let's take a look at each of the options. So option A says, all points of intersection lie on the line y equals x. Can we think of a situation where this would not be true? There are functions which fit these conditions that have intersections with their own inverse, which are not on the line y equals x. Here's a simple example. The line y equals minus x is its own inverse, and so it intersects itself at all points, including points that are not on the line y equals x. So we can rule out option A. Option B says, none of the points of intersection lie on the line y equals x. Now, while it is possible to have intersections that are not on the line y equals x, is it possible for these kinds of functions to have at least one intersection, but none on the line y equals x? Let's think about that. Let's say our graph and its inverse have an intersection at some point AB. Then, because they're inverses, they will also have to have an intersection at the point BA. Could these be the only points of intersection? Well, we know that the functions exist for all real numbers x, and the fact that the derivatives also exist for all real numbers x means that the functions are continuous, which means at some point between these two intersections, they will also cross the line y equals x and have an intersection with each other on that line. So we can rule out B. Option C, at no point of intersection are the tangents to the graphs parallel. So, would it be possible for them to have tangents that are parallel at a point of intersection? Well, let's consider the tangent to the function, dy dx. We know that the tangent or the gradient of the inverse would be 1 over dy dx. Could they be equal? Well, it would be possible if dy dx equals 1, because the reciprocal of 1 is 1. So let's say, for example, the function is tangent to the line y equals x, then its inverse would be as well. And the gradients of their tangents would both be 1, and they'd be parallel. So we can rule out option C. Let's check option D. At no point of intersection are the tangents of the graphs perpendicular. Why would this be true? So let's think again about the gradient to the function and its inverse. For the tangents to be perpendicular, the gradient of one has to equal the negative of the reciprocal of the other. So if we reciprocate the gradient of the inverse, we get dy dx back, but we'd have to make it negative. Could they be equal? The only way for them to be equal is for dy dx to be 0. So we could think of a function who has a gradient of 0 as it perhaps crosses the line y equals x, and then its inverse. So what's the problem here? Well, it comes down to the statement that the derivatives of f of x and f inverse of x exist for all real numbers x. If the gradient of the function or its inverse at a specific point is 0, then the inverse function would be 1 over 0 at that point, which means it would not exist. It would have a vertical asymptote. So that's why D is the correct option. Question 10. Which of the following could be the graph of a solution to the differential equation dy dx equals sine y plus 1? So dy dx represents the gradient on the solution curve. And in this case, it depends only on the y coordinate. So if we were to graph the direction field, the gradients would appear the same across horizontal lines because it does not depend on x. But let's start with sine y. We know sine of y would go between the values of -1 and 1. What produces these two extremes? Well, sine y equals -1 when y is equal to -pi over 2, 3pi over 2, etc. Let's explore values of y between these two extremes and see what happens to dy dx. We'll start with -pi over 2, 0, pi over 2, pi, and then 3pi over 2. Okay, so again, when y is -pi over 2, sine of y starts off being -1. Then at 0, sine y is 0. At pi over 2, it's 1. At pi, it's 0 again. And then at 3pi over 2, back to -1. So that's one cycle of what happens to the only thing with a prenumeral in it. Now, what happens to dy dx then, if it is sine y plus 1? So, at -pi over 2, it's 0. At 0, it's 1. At pi over 2, it's 2. At pi, it's 1. And then 3pi over 2, back to 0. So let's see what the direction field might look like. Okay, at -pi over 2, dy dx is 0. So we have horizontal directions. Then at 0, it's 1. Then at pi over 2, it gets steeper, being 2. Then at pi, back to 1. Finally, at 3pi over 2, back to 0. So we should see this S-like shape as well as horizontal asymptotic behavior as we approach -pi over 2, 3pi over 2, and so on. So which option best fits this direction field? At first glance, we would say B, but we can take a look at each option. Option A is not it. That's because our direction field does not indicate any vertical asymptotic behavior. Option C would have the gradient increasing, but then decreasing. And if we look on our direction field, We never have a negative gradient. Option D would be close, but we know that our solution would not be able to cross over those horizontal lines, which would form a horizontal asymptote. So, B is the correct answer. Question 11a. For the vectors u equals I minus j and v equals 2i plus j, evaluate each of the following. Part 1, u plus 3v. Okay, let's take u and add 3 times vector v. So we can expand and multiply each component of the second vector by 3. And then adding the I components together and the j components together. So it should be 7i plus 2j. Part 2, u dot v. So we need to take the dot product of u and v. The dot product would involve multiplying I with I component and j with j component and then adding the results. And so we get 1. Remember, the dot product is sometimes called the scalar product because the result is a scalar, as in a non-vector. Okay, before we move on, I can show you what we can do to check our answers on the Casio FX8200. First, from the home screen, we can go to vector mode. And we can define the 2 vectors we're working with. We're working with 2-dimensional vectors. The first one's components are 1 and -1. The second vector's components are 2 and 1. Now, let's take the first vector plus 3 times the second. And you see the components, 7 and 2. Now, let's take their dot product. Start with the first vector, then to take the dot product, go to vector calculations and dot product. Now the second vector. And we get 1. Now, it's still important to show you're working out on your test in order to get full marks. However, using a calculator, you can check your answers to make sure you've done it correctly. Question 11b. Find the exact value of the integral from 0 to 1 of x over the square root of x squared plus 4 dx using the substitution u equals x squared plus 4. Okay, let's take that u substitution and find du as well. Du would be 2x dx. In the integral, we only need to replace x dx since we already have the x squared plus 4 covered. So let's divide by 2. So we'd have 1/2 du is equal to x dx. Since it's a definite integral, let's also redefine the limits of integration in terms of u. When x is 1, we'd put that into the definition of u as in x squared plus 4 to get 5. And when x is 0, we get 4. We're ready to rewrite this integral. I'll put the 1/2 that was attached to the du in front of the integral. We'll just write this in index form. And now we can integrate. The 1/2's cancel, so we're just going from 4 to 5. And we get the square root of 5 minus the square root of 4, which is root 5 minus 2. Question 11c. Find the coefficients of x squared and x cubed in the expansion of 1 minus x over 2 to the power of 8. Okay, we don't have to do the entire expansion. Let's consider the general term. So on the reference sheet, we'll go down to the last page. This here is the general term of a binomial expansion. Now, what's inside of our bracket looks a little different, but we can substitute in 1 where x is, and negative x over 2 where a is. Of course, in our case, n is 8. I like to isolate x so I can focus in on its exponent. So we're looking for when x is to the power of 2 and the power of 3. So that just means we need to set r to 2 and r to 3, and then see what the coefficients would come out to. In this calculator, you can go to the catalog, go to probability, and choose the combination button. So the coefficient would be 7 when r is 2. And negative 7 when r is 3. Question 11D. The vectors u equals a 2 and v equals a minus 7, 4a minus 1 are perpendicular. What are the possible values of a? Okay, remember that when two vectors are perpendicular, their dot product has to equal 0. So let's take a look at that dot product. Remember, the dot product is each of the x components multiplied with each other and the y components multiplied with each other and then added together. So let's expand and see if we can solve for a. So it's quadratic. Let's factorize. So a could be negative 2 or positive 1. Question 11e. Express the square root of 3 sine x minus 3 cosine x in the form r sine of x plus alpha. In order to combine these two trigonometric functions with the auxiliary angle method, you can do so without memorizing anything by using angle sum identities. So let's look at those compound angle identities on the reference sheets. We're trying to get it in the form of sine of x plus alpha, which will fit the sine angle sum identity. Sine A cosine B plus cosine A sine B. So we'll write root 3 sine x minus 3 cosine x equals r times sine x cosine alpha plus sine alpha cosine x. Now all we need to do is equate the coefficients for sine and for cosine. Of course, the coefficient for sine on the left-hand side is root 3. On the right-hand side, it would be r times cosine alpha. So r cosine alpha equals root 3, which gives us cosine alpha is root 3 over r. The coefficient for cosine on the left-hand side is negative 3. On the right-hand side, it would be r, again, because we would have to expand the bracket, sine alpha. So r sine alpha equals negative 3. So sine alpha equals negative 3 over r. Now, there may be slightly different approaches. What I usually do is I draw a right triangle with angle alpha in it. Cosine is the adjacent over the hypotenuse. So adjacent to alpha is root 3. And sine is opposite of hypotenuse. So opposite of alpha is -3, while of course the hypotenuse is r. So as you can see, to find r, we use Pythagoras' theorem. To get alpha, we could use inverse tan. Be careful though, because we need to pay attention to what's positive and what's negative. We have cosine positive and sine negative. That means we're in quadrant 4. What's alpha? Now, if we rationalize that denominator, we might recognize what this angle should be. We know tan 60 is √3/1, so alpha will be -π/3. So we have √3 sine alpha minus 3 cosine alpha would equal 2√3 sine of x minus π/3. Question 11F. Solve x over 2 minus x is greater than or equal to 5. Okay, the most common technique I see taken for these kinds of questions is to multiply both sides of the inequality by 2 minus x squared. We'll also note for ourselves, just in case, that x cannot equal 2. The reason we multiply by 2 minus x squared is while 2 minus x could be negative, 2 minus x squared has to be positive, so we're safe in the direction of the inequality, remaining the same. Now what we have to do is expand both sides. Then we get everything on one side. I'd rather be working with a positive x squared coefficient. So let's move these two to the right-hand side. And let's do ourselves a favor, flip this around, and also divide through by 2. Okay, so we'll have to solve this quadratic, find out when it's equal to 0, and then see when it's less than or equal to 0. Now, it's non-monic, so we want two numbers that multiply to 30 and add to -11. -6 and -5 will do the trick. So, this would be 0, 1, x is 2, or 5/3. Now what we can do is consider this as an upwards facing parabola, which means it would be less than or equal to 0 between 5/3 and 2. Now, it does say less than or equal to 0, but don't forget what we said to ourselves, that x cannot equal 2. So we'll change that part to an open circle, and we have the middle. So in inequality form, 5/3 is less than or equal to x is less than 2, or in interval form, square bracket 5/3 to 2, round bracket. Question 12a. A direction field is to be drawn for the differential equation dy dx equals x minus 2y over x squared plus y squared. On the diagram on page 1 of the question 12 writing booklet, clearly draw the correct slopes of the direction field at the points P, Q, and R. Okay, I have here the diagram from the question 12 writing booklet. We need to draw the correct slopes of the direction field at P, Q, and R. So let's start with P. At P, x is -1 and y is 1. So dy dx would be x, -1, minus 2 times y, which is 1, over negative 1 squared plus 1 squared. So that's negative 3 over 2. So just a bit steeper than a gradient of negative 1. We might have something like that. At Q, x is 1 and y is 1. So dy dx would be 1 minus 2 times 1 over 1 squared plus 1 squared, negative 1/2. So we'd have something like that. At R, x is 2 and y is 1. So dy dx would be x, 2, minus 2 times y, which is 1, over 2 squared plus 1 squared. So we'd have a horizontal slope. Question 12b. A sports association manages 13 junior teams. It decides to check the age of all players. Any team that has more than 3 players above the age limit will be penalized. A total of 41 players are found to be above the age limit. Will any team be penalized? Justify your answer. Okay, you may recognize this as an application of the pigeonhole principle. Let's see what would happen if we divided 41 amongst the 13 teams. That would be 3 remainder 2. So even if we spread the over the age limit players equally as much as we could amongst those 13 teams, there would be 2 left over. Now, those 2 could go into the same team or 2 different teams. So the most we could say is that there is at least one team that would have more than 3 players over that age limit. Don't forget to cite the pigeonhole principle. So you could write something like, by the pigeonhole principle, at least one team will have at least 4 players above the age limit and will be penalized. Question 12c. Find the equation of the tangent to the curve y equals x times arctan x at the point with coordinates 1 pi over 4. Give your answer in the form y equals mx. Alright, arctan is another way of writing inverse tan. Now, of course, if we want to find the equation of the tangent to the curve, we need the gradient, so we need the derivative. Since this is a product of 2 functions of x, we'll have to use the product rule. If you need a reminder, it's on the formula sheets. The derivative of u times v is u times the derivative of v plus v times the derivative of u. We can also check the derivative of the inverse of tan. Including the chain rule, the derivative of inverse tan of f of x is the derivative of f of x over 1 plus the square of f of x. So let's say x is u and inverse tan is v. So the derivative would be something like tan inverse of x plus x over 1 plus x squared, just depending on what order you put it in and how you might simplify it. The important thing here is that we want to know what its value is when x is 1. Now, tan inverse of 1 is pi over 4, and then the fraction becomes 1/2. That's the gradient of the tangent at the point 1 pi over 4. So now let's use point gradient form to create the equation of that line. Of course, 1 is x1 and pi over 4 is y1. All right, and let's put that into y equals mx plus c form. I might combine that gradient so it'll be a nicer coefficient of x. I'll leave it separate for the y-intercept, because the pi over 4s will cancel nicely. So the line would be y equals pi plus 2 over 4 x minus 1/2. Question 12D. In a room with temperature 12 degrees Celsius, coffee is poured into a cup. The temperature of the coffee when it is poured into the cup is 92 degrees Celsius, and it is far too hot to drink. The temperature T in degrees Celsius of the coffee, T minutes after it is made, can be modeled using the differential equation dt dt equals k times T minus T1, where k is the constant of proportionality and T1 is a constant. Part 1. It takes 5 minutes for the coffee to cool to a temperature of 76 degrees Celsius. Using separation of variables, solve the given differential equation to show that T equals 12 plus 80 times e to the t over 5 ln of 4/5. All right, let's start solving that differential equation by separation of variables. Let's get the capital T stuff on the left and the lowercase t stuff on the right. Now we integrate both sides. The integral on the left will require a logarithm. Let's find that constant. Now we know when t is 0, that capital T is 92. So C is ln of 92 minus T1. Now if you've done modified exponential growth or decay, you know that T1 should be the room temperature. But if you wanted to show it, consider what happens as T goes to infinity. Since the temperature is decreasing, we know that K will be negative, and as T goes to infinity, e to the kt will go to 0. And then the temperature of the coffee will go to room temperature. So we have 12 minus T1 equals 0, which means that T1 is 12. Also, knowing that T starts above 12 and approaches 12 over time, T minus T1 will always be positive, and so we don't need those absolute values. So far we have capital T equals 80 e to the kt plus 12. Now we just need to find k. And we'll plug in that second data point, that after 5 minutes the temperature has cooled to 76 degrees. Let's solve for k. So k is 1/5 ln of 4/5. So now we have our completed model that t is, if we change the order of addition, 12 plus 80 e to the 1/5 ln of 4/5 multiplied by t. We can put the t in the numerator of 1/5, t over 5 ln 4/5. Part 2. The optimal drinking temperature for a hot beverage is 57 degrees Celsius. Find the value of T when the coffee reaches this temperature giving your answer to the nearest minute. Okay, let's use what we found in the previous parts, and we're going to make t57 and solve for lowercase t. So let's calculate 5 times ln of 9 over 16 divided by ln of 4 over 5. To the nearest minute, that is 13 minutes. Question 12e. A game consists of randomly selecting 4 balls from a bag. After each ball is selected, it is replaced in the bag. The bag contains 3 red balls and 7 green balls. For each red ball selected, 10 points are earned, and for each green ball selected, 5 points are deducted. For instance, if a player picks 3 red balls and 1 green ball, the score will be 3 times 10 minus 1 times 5, 25 points. What is the expected score in the game? Okay, you may recognize this as a binomial probability. What are the parameters? Well, what's going to be our p? How about we'll make it the desired outcome of getting a red ball? 3 out of 10 are red, so p will be 3 out of 10. 4 balls are selected, so n will be 4. We need to find the expected number of successes, as in red balls selected. In binomial probability distributions, the expected outcome is n times p. Which in this case equals 6/5. That means if we're drawing 4 balls, the expected number of green balls will just be 4 minus 6/5. That's 14/5. So the expected outcome would be the expected number of red balls, 6/5, times 10, the points earned per red ball, plus 14/5 times -5, the number of points deducted for a green ball. So the expected score is -2. Question 12f. Use mathematical induction to prove that 15 to the n plus 6 to the 2n plus 1 is divisible by 7 for all integers n greater than or equal to 0. So let's start with our base case. See if it's true for n equals 0. When n equals 0, that expression comes out to 7, which of course is divisible by 7, so it's true for n equals 0. Next, we assume it's true for some n equal to k. Now, in divisibility proofs, what you want to do is set the expression equal to 7 times an integer, which is another way of saying that it's divisible by 7. Now let's see if it's true for n equals k plus 1. So at n equals k plus 1, we'd have 15 to the k plus 1, plus 6 to the 2 times k plus 1, plus 1. And we want to show that that's equal to some integer times 7. Maybe we'll use q. Let's start with the left-hand side. I'll simplify that exponent to be 2k plus 3, and let's see how we might bring the assumption into this. According to our assumption, 15 to the k plus 6 to the 2k plus 1 is 7 times p, some integer. Maybe we can separate 15 to the k, we can replace it in terms of that assumption. 15 to the k plus 1 is equivalent to 15 to the k times 15, according to index laws. Now, if we look at our assumption and solve for 15 to the k, it would be 7p minus 6 to the 2k plus 1. So let's substitute that in for 15 to the k. Let's expand. I might leave that as 15 times 7 because I am looking for factors of 7. Sometimes the next step is about asking ourselves, what can we do here? Well, we could factorize some number of factors of 6 from the last two terms. When we factorize, we take the lowest exponent out. In this case, 6 to the 2k plus 1, since 2k plus 1 is smaller than 2k plus 3. Now I have taken out the minus, so this will change the second term to negative. By factorizing out 6 to the 2k plus 1, I'm subtracting 2k plus 1 from 2k plus 3, leaving behind 2, 6 to the power of 2. What's 15 minus 6 squared? It's negative 21. 21 is a multiple of 7. So, if we factorize out that 7, it will make it very clear that we have a number divisible by 7. (15p) plus 3 times 6 to the 2k plus 1 would be an integer. So, 7 times an integer is divisible by 7. And so we've proven that it's true for n equals k plus 1. And we finish off by saying, by the principle of mathematical induction, the statement is true. You can write the original statement if you like. Question 13a. 3 different points, A, B, and C, are chosen on a circle centered at O. Let vector A be OA, vector B, OB, and vector C, OC. Let vector H be A plus B plus C, and let H be the point such that OH is equal to vector H, as shown on the diagram. Show that BH and CA are perpendicular. Okay, we're being asked to show something about BH and CA. So let's write down what we know about BH and CA. We're working in terms of vectors A, B, C, and H. So can we define BH in terms of those vectors? BH would be this vector here. So that means that BH is equivalent to vector H minus vector B. Similarly, CA is equivalent to vector A minus vector C. Let's also remember that vector H is equal to A plus B plus C. Now, what is it for two vectors to be perpendicular? Well, for one, we know that their dot product would be 0. Now, we don't have much to work with in terms of calculating dot products, but we could see what happens in the algebra of dot products. Let's replace H with A plus B plus C. Of course, these B's cancel, so this becomes A plus C dotted with A minus C. Now, we know that the dot product is distributive, so if we expand this, we'll get A dot A plus A dot C minus A dot C, minus c dot c. Of course, those middle terms will cancel. And remember that when you dot a vector with itself, the result is the length of that vector squared. Now let's not forget that we are in a circle here. The three vectors, a, b, and c, are radii of the same circle. Their lengths are equal. So the length of a squared minus length of c squared would equal 0. Thus we can conclude that the vectors are perpendicular since their dot product equals 0. Question 13b. A solid of revolution is to be found by rotating the region bounded by the x-axis and the curve y equals k plus 1 times sine of kx, where k is greater than 0, between x equals 0 and x equals pi over 2k, about the x-axis. Find the value of k for which the volume is pi squared. Alright, the volume of the solid of revolution is calculated by summing the areas of the disks along the axis of rotation. The radius of each disk is equal to the height of the function for that value of x. The area of a circle is pi r squared. And again, the radius is the height of the function. The function here is k plus 1 sine of kx, and we're squaring that. So let's sum these disks from 0 to pi over 2k. Note that I've applied the squared to each factor inside of that bracket. Now take note that k plus 1 is just a constant, so we can take k plus 1 squared along with a pi out front of that integral. Now we know our approach to integrating sine squared is to use the double angle formulas. Let's look at the reference sheets. These down here are for convenience with integration. Sine squared of nx is equal to 1/2 times 1 minus cosine of 2nx. So we'll rewrite this integral. And now we can integrate. We can pull the half out front of the integral as well. The integral of 1 with respect to x is x, and the integral of negative cosine is positive sine. With the reversing of the chain rule, we have to divide by the 2k, or times by 1 over 2k. Now let's put in those limits of integration. Let's see what we get. Now, 2k times pi over 2k is just pi. Sine of pi is 0. In that other bracket, we have 0 plus sine of 0. Sine of 0 is also 0. So we just get pi squared, k plus 1 squared, over 4k. Remember, we're trying to find the value of k, which would make this volume equal to pi squared. Let's solve for k. Well, the pi squareds cancel, and we can times the 4k over. This looks like it'll be quadratic. And we get k equals 1. Question 13c. The function f is defined by f of x equals sine x for all real numbers x. Let g be the function defined on the interval -1 to 1 by g of x equals arcsine of x. Is g the inverse of f? Justify your answer. So if you remember how we created the inverse trigonometric functions, we had to restrict the domain of sine and cosine and tangent, so they would be invertible. Sine is not invertible on its natural domain. I'll draw a quick sketch. So that's sine of x defined on all real numbers x. And that's sine inverse, which is normally defined on -1 to 1. So the answer will be no. G is not the inverse of f. What we could say is that f is not invertible if it's defined for all real x. For G to be the inverse of f, we would have to restrict its domain so that it is equal to the range of arcsine of x. Remember, the range of arcsine is -π/2 to π/2. So the domain of sine would have to be restricted to -π/2 to π/2. Question 13D. The monic polynomial p has degree 3 and roots alpha, beta, gamma. It is given that alpha squared plus beta squared plus gamma squared is equal to 85, and the derivative of p at alpha plus the derivative of p at beta plus the derivative of p at gamma is equal to 87. Find alpha beta plus beta gamma plus gamma alpha. Let's start by considering the square of alpha plus beta plus gamma, which is how we usually get to alpha squared plus beta squared plus gamma squared. If we expand that, we'll get alpha squared plus beta squared plus gamma squared plus alpha beta and alpha gamma, beta alpha and beta gamma, gamma alpha and gamma beta. When we combine like terms and factorize out the 2, this simplifies to alpha squared plus beta squared plus gamma squared plus 2 of alpha beta plus alpha gamma plus beta gamma. Now, that expression in the bracket is what we're trying to find. Now we know alpha squared plus beta squared plus gamma squared is 85, so we can replace that. And if we can find the sum of alpha, beta, and gamma, we'll be able to solve for the expression that we're looking for. Now, what can we do with the knowledge about the derivative of polynomial p? Well, we know polynomial p is monic, so we can say that it's something of the form x cubed plus a coefficient times x squared, a coefficient times x, and a constant. Let's consider its derivative. Now, if we substitute in alpha and beta and gamma and sum them, we'll get this equation. Let's get the squared alpha, beta, and gammas together, the non-squared alpha, betas, and gammas together, and the constants. This gives us that 3 times alpha squared plus beta squared plus gamma squared plus 2b times the sum of alpha, beta, and gamma plus 3c is equal to 87. Now, we know what alpha squared plus beta squared plus gamma squared equals. That's 85. So what about b and c? Well, we can get expressions for b and c in terms of alpha, beta, and gamma if we go back to the original cubic polynomial. We know that negative b over a, and in this case it's monic, so a is 1, is equal to the sum of the roots, alpha plus beta plus gamma. And we know that C over A, so in this case C, is equal to the sum of the product pairs, alpha beta, alpha gamma, and beta gamma. So let's replace B and C with these expressions. Now, alpha plus beta plus gamma is going to times by itself, so we'll have that squared. And let's move that 255 to the other side. Now, essentially, we have simultaneous equations in terms of the sum of alpha, beta, gamma, and the sum of their paired products. So if we go back to this equation, we can replace the sum of alpha, beta, and gamma squared with what we have there on the right. And then we could just solve for the sum of the product pairs. So when we move the 170 to the other side and combine the two brackets of alpha beta, alpha gamma, and beta gamma, we get negative of alpha beta plus alpha gamma plus beta gamma is equal to 2, which means alpha beta plus alpha gamma plus beta gamma equals negative 2. Question 13e. A chocolate factory sells 150-gram chocolate bars. There has been a complaint that the bars actually weigh less than 150 grams, so a team of inspectors was sent to the factory to check. They randomly selected 16 bars, weighed them, and noted that 8 bars weigh less than 150 grams. The factory manager claims 80% of the chocolate bars produced by the factory weigh 150 grams or more. Part 1. The inspectors used the normal approximation to the binomial distribution to calculate the probability P of having at least 8 bars weighing less than 150 grams in a random sample of 16. Assuming the factory manager's claim is correct, calculate the value of P. Now, the information on page 18 that the question refers to is a standard normal table, which is this table here. So we'll come back to this when we need it. All right, so we're looking at a binomial distribution, and we'll be using a normal approximation to it. So what is P, the probability of a so-called success in this case? Let's say we follow what the inspectors were doing, and they were looking at the chances of getting 8 bars weighing less than 150 grams. So let's make P the chances of getting a bar weighing less than 150 grams, which in this case, if the manager's claim is correct, would be 20%. So we'll assume P is 20%. Of course, N is the number of trials, in this case, 16. And we're trying to work out what is the probability of getting 8. All right. Let's say we have a random variable called x, which is the number of bars weighing less than 150 grams in a sample of 16. So x would have a binomial distribution, p 0.2, and 16. And we want the probability that x is at least 8, so greater than or equal to 8. Now, when we use a normal approximation to the binomial distribution, we'll define a new random variable, maybe we'll call it y, normally distributed, whose mean is the expected value of x. In binomial, that's n times p, and whose variance is equal to the variance of the binomial, which is n times p times q. Q, of course, is 1 minus p. Now, if you do need a reminder, on the expected value and variance of a binomial distribution, check the reference sheets. You'll see them here. That's what we're going to use as the parameters of our normal distribution. So what's the expected value? N times P, 16 times 20%. Let's use the decimal, 3.2. What's the variance? N times P times Q. Remember, Q, again, is 1 minus P, so 80% in this case. 2.56. Now, when using a normal approximation to a binomial, especially with small n, we should use a continuity correction. So we're looking at the probability of getting at least 8. But binomial is discrete and the normal distribution is continuous. So we'll take half a unit to the left of this and find the probability of getting 7.5 or more on this normal distribution. So the probability that x is greater than or equal to 8 is approximately equal to the probability that y is greater than or equal to 7.5. To work that out, let's find out what the z-score is of 7.5 in this normal distribution. Remember, our mean is 3.2 and our variance is 2.56, so our standard deviation is the square root of 2.56. Don't forget to square root that in the z-score formula. So we get 2.69, I'll round it. Z tables typically go to 2 decimal places. So let's find 2.69 in the Z table provided. All right, we'll scroll down to the 2.6 row. And 2.69, the 0.09 is the last column there. So we're looking at 0.9964. Now, standard normal table typically gives us the probability up to a certain z-score. So the probability of being above that is going to be 1 minus. (0.0036), as in 0.36%. So what that means is if the manager's claims are true, there was a 0.36% chance of the inspectors finding 8 out of 16 of the bars less than 150 grams. Part 2. The factory manager disagrees with the method used by the inspectors, as described in Part 1. Explain why the method used by the inspectors might not be valid. All right, so Part 1 seemed like some pretty damning evidence, but the manager is disagreeing, and there seems to be a reason why the results might not be valid. So we have to remember what we learned about when it's appropriate to use the normal approximation of the binomial distribution. And in that case, our n has to be sufficiently large such that n times p and n times q, as in 1 minus p, are at least, we say, roughly greater than 5. Let's take a quick look at np and nq. We worked that out earlier to be 3.2. And this one's 12.8. But they both need to be at least 5 or higher, as in there has to be a chance of getting 5 successes and 5 fails with your sample size. So 3.2 is pretty low, which means using the normal approximation would not necessarily be appropriate here. So So we'd say something like, to use the normal approximation to the binomial distribution, n must be sufficiently large such that np is greater than or equal to 5 and n1 minus p is greater than or equal to 5. Therefore, the method is not valid. Question 14a. Find the particular solution to the differential equation of x minus 2 times dy dx equals xy that passes through the point 0, 1. Okay, we have a differential equation, and it's one that we can solve by separation of variables. Let's get the x stuff on one side and the y stuff on the other. Since dy is in the top of the dy dx, I'm going to move the x minus 2 and the dx onto the right, and I'm going to move the y from the right onto the left. Now we integrate both sides. Okay, on the right-hand side here, we can't integrate x over x minus 2 as it is. Now, there's a quick way to change that. Technically, we can also do polynomial long division. It would be a short long division, but that is an option. The quicker way might be to add and subtract 2 in the numerator. And then splitting that into 2 fractions. The first being x minus 2 over x minus 2, which is 1, and the second, 2 over x minus 2. So integrating that, we get x plus 2 ln of x minus 2 plus c. Now the particular solution depends on the point that this goes through, which is 0, 1, and that'll help us find the value of c. So we have x being 0 and y being 1. So c is negative 2 ln 2. Now, seeing what happened when we plugged in that x and y points also gives us an idea on what we need to do with those absolute values. We didn't need the absolute values when we plugged in the y-coordinate of 1, but we did when we plugged in the x-coordinate of 0. Now, one way to replace an absolute value when the result is negative is to throw a negative in front of the expression, which will cancel out the negative, which has the same effect as an absolute value. Now, we could fix this up a little bit. We can use our log laws even on the right-hand side. I distributed the negative to x minus 2, and then with log laws, put that over 2. Now the last step is to take e to the power of both sides. Of course, with index laws, the sum of the powers can be split up into a product of the bases to each power. Now, so we can use that log law to cancel out the log and that e. We're going to put the coefficient 2 as a power of the inside of the log. So we get 2 minus x over 2 squared times e to the x. If we want it to look a little nicer, we could write 2 minus x squared over 4 e to the x, or something like that. And that's our answer. Question 14b. The vectors u and v are not parallel. The vector p is the projection of u onto the vector v. The vector p is parallel to v, so it can be written as lambda naught times v for some real number lambda naught. Prove that the length of u minus lambda v is smallest when lambda equals lambda naught by showing that for all real numbers lambda, the length of u minus lambda naught v is less than or equal to the length of u minus lambda v. All right, first I'm going to draw a diagram to help us make sense of what this is all talking about. So we have vectors u and v not parallel, and the projection of u onto v. So let's say this is u and this is v. Lambda v is just a scalar multiple of v. Something like that. And u minus lambda v would be something like that. And we're trying to show again that the length of this vector is smallest when lambda is lambda naught, and lambda naught is when we're looking at the projection. So let's compare to the projection. So the projection of u on v is what you get when you take a line from the end of u perpendicularly to v and draw a vector parallel to v up to that point. So this is what we're calling lambda naught v. And we're looking at that perpendicular line we drew as the vector u minus lambda v, where lambda is specifically lambda naught. So essentially what we're trying to prove is that the shortest distance to a line is perpendicularly. So what can we do? Well, we can start with the projection of u onto v. Okay, the formula for a projection is something you need to know. It's not on the reference sheet. Here's how I remember it. You start with the vector you're projecting, which is u. Everything else is the vector you're projecting onto. So it's u dotted with v over v dotted with itself, which is sometimes written as v dot v. Sometimes it's written as the length of v squared because that's equivalent to v dot v. And that's a scalar because the dot product is a scalar, length is scalar, and we times that as a scalar multiple onto vector v. So according to essentially the definition of a projection, the lambda naught here in the projection version of u minus lambda v is what we have there in front of v, the u dot v over v dot v, or length of v squared. Now, how are we going to get the length of u minus lambda v? Well, we could note that that forms a triangle. And we could maybe look at something like the cosine rule to get the length of u minus lambda v. So in the cosine rule, we'd have the length of u minus lambda v squared is the length of u squared plus the length of lambda v squared minus 2 times the length of u times the length of lambda v times cosine of theta, the angle between the vectors. We'll call that theta. So we can pull a scalar out of a length or absolute value of a vector. So this will become the length of u squared plus lambda squared times the length of v squared minus 2 lambda times the length of u times the length of v cosine theta. Now, we are trying to find the value of lambda that minimizes that length of u minus lambda v. Now, yeah, it's squared on the left-hand side, but whatever minimizes the square of a variable will minimize that variable as well. So we can see that on the right-hand side, it's essentially quadratic in terms of lambda. So let's rearrange. And as it's quadratic, leading coefficient positive in a way that's an up-facing parabola, which has a minimum. And the minimum occurs at the value of lambda, which is equal to negative b over 2a. That's where the vertex is of the parabola. In this case, the b is all of this. The negatives cancel. And a is this here. Now, one of the v lengths will cancel. The 2's will cancel as well. So that's just length of u times cosine theta over length of v. We can get an expression for cosine theta in terms of u and v via the dot products. So let's take a look at the reference sheet. So this here tells us that u dot v is the length of u times the length of v times cosine of the angle between them. Solving that for cosine means we have cosine theta is u dot v over length of u times length of v. Now, the lengths of u will cancel. So we get u dot v over the length of v squared, which, remember, is lambda naught. So that proves that lambda naught, as in the scalar multiple of v, that is the projection of u onto v, minimizes the length or the distance from the end of u to the vector v. Question 14c. A video game designer wants to include an obstacle in the game they are developing. The player will reach one side of a pit and must shoot a projectile to hit a target on the other side of the pit in order to be able to cross. However, the instant the player shoots, the target begins to move away from the player at a constant speed that is half the initial speed of the projectile shot by the player, as shown in the diagram below. The initial distance between the player and the target is d. The initial speed of the projectile is 2u, and it is launched at an angle of theta to the horizontal. The acceleration due to gravity is g. The launch angle is the only parameter that the player can change. Taking the position of the player when the projectile is launched as the origin, the positions of the projectile and target at time t after the projectile is launched are as follows. Vector r, p for projectile, is 2ut cosine theta, 2ut sine theta minus g over 2t squared, and vector rt for target is d plus ut, 0. Show that for the player to have a chance of hitting the target, d must be less than 37% of the maximum possible range of the projectile to two significant figures. We want to know when the projectile reaches the ground level. So let's take the vertical components of the projectile and find when it's equal to 0. Let's factorize it. Okay, I also took out the 1/2, so I don't need to worry about the fraction. Now, this will equal 0 when t is 0. Of course, that's just the start, when the projectile starts at ground level, or when t is 4u sine theta over g. Now, we want to know if the projectile hits the target, so we need to know its horizontal position at this time. So let's put this time into the horizontal component of the projectile. So this becomes 8u squared sine theta times cosine theta over g. Now, it's not so nice having both sine and cosine of theta in our expression, but you may recognize sine times cosine as related to double angle identities. So 2 sine theta cosine theta is sine of 2 theta. So we'll have to use a factor of 2 from the 8, which leaves behind a 4. So that'll be a little easier when we need to solve for theta. Now, This question has a lot to do with the maximum range of the projectile. So let's determine its maximum possible range. Now the only thing that can change again is theta, as was stated in the question. Of course, we're going to consider angles from 0 to pi over 2, so sine will vary from 0 to 1. It's in the numerator, so we'd be interested when sine is its largest. So sine to theta is a maximum value of 1 when 2 theta is pi over 2, so theta is pi over 4. Sine being 1 in that case, we get 4u squared over g as the maximum possible range. Now, of course, we want the projectile to hit the target. So we want to know what is the horizontal position of the target at this time when the projectile hits ground level. Okay, so let's put the t we got here when the projectile hits the ground into the horizontal component of the target's position. So that was d plus u times t, and again we want to know where it is when t is 4u sine theta over g. So the projectile hits the target when the horizontal position of the projectile, we have two versions here. We're about to combine it with this, which involves only sine theta, so we don't want to combine that with a sine 2 theta, so we might go back to the sine theta cosine theta version. So the projectile hits the target when 8u squared sine theta cosine theta over g equals to the horizontal position of the target, which is d plus 4u squared sine theta. And of course, we need to find out what's the maximum range of d. Remember, d was the width of the pit. So this is a game designer making sure that the challenge is able to be completed in the first place. So let's solve for d. We've got both sine theta and cosine theta, but we could factorize sine theta, as well, of course, as 4u squared over g. So we have d is equal to 4u squared over g, sine theta times 2 cosine theta minus 1, and we want to know what its max value is. Again, this is all coming from projectile hitting the target, so if that's going to happen, what is the max value here of d? Now, as we know, u is a constant, g is a constant. The only thing that can vary is the angle of the projectile. So we want to worry about the max value of sine theta times 2 cosine theta minus 1. Well, in general, how can we find a maximum of a function? We could take its derivative. This is a product rule. Okay, we have a mix of cosines and sines. We got a cosine squared and a cosine, so maybe quadratic and cosine. Let's get an identity to replace sine squared in terms of cosine squared. From the Pythagorean identity, we know that sine squared is 1 minus cosine squared. So we get 4 cosine squared theta minus cosine theta minus 2. Now, this is the derivative of the function we're trying to find a maximum on, and maximums occur at stationary points. So we're going to set this equal to 0. We'll have to solve it with the quadratic formula. We'll take inverse cosine of that answer. Let's use degrees since we're doing a physical application with angles. And we get about 32.5 degrees. Now, I'm ignoring the minus part of the plus or minus because we are just dealing with angles from 0 to pi over 2. And I don't need obtuse angles here. The sine theta times 2 cosine theta minus 1 is maximized, which occurs when theta is 32.5 degrees. Now, remember what we're trying to find is that the max value of d is a certain percentage of the maximum range. So let's go back to the maximum range. So remember that the maximum range is the 4u squared over g. And then let's compare that to the value of d. So we'll use this whole expression. You can see there the 4u squared over g, that is the max range. And we're going to see what sine theta 2 cosine theta minus 1 comes out to. And we get 0.37 to two significant figures, which shows that the max value of d is about 37% of the max range of the projectile. Question 14D. An airline company that has empty seats on a flight is not maximizing its profits. An airline company has found that there is a probability of 5% that a passenger books a flight but misses it. The management of the airline company decides to allow for overbooking, which means selling more tickets than the number of seats available on each flight. To protect their reputation, management makes the decision that no more than 1% of their flights should have more passengers showing up for the flight than available seats. Given management's decision, and using a suitable approximation, find the maximum number of tickets that can be sold for a flight which has 350 seats. Okay, so we have the probability of a passenger showing up as 95%. So we'll say P is 0.95. And in a way, this will be a binomial probability distribution since we have multiple trials of success and fail. Success, in this case, will be passenger shows up. Now what we want to do is find the value of n for which we get a probability of 1% or less for more than 350 successes. So our original variable is binomial, p 0.95, n is going to be n for now, but we'll approximate it with a normal distribution. Maybe we'll say that's y. Now when we approximate, again, the expected value of the binomial will be used as the mean or expected value of the normal. So that's n times p, so 0.95n, and the variance is n times p times q. So n times 0.95 times 0.05. So 0.0475n. So we're looking for the probability that x is greater than 350. And we'll approximate that with the probability that y is greater than 350. Now, since we have such a large n, the continuity correction here isn't as necessary to do. The difference it would make would not likely be noticeable in our answer. So we'll keep it as 350, and we want this probability to be less than or equal to 1%. So we'll set that equal to 0.01. Now, to find probabilities on a normal distribution, we find the z-score. So the z-score for 350 will be 350 minus the mean, which is 0.95n, divided by the standard deviation. Now again, Be careful here. What we have in the normal distribution up here is the variance. Make sure you square root that when you put it into the z-score formula. And we know the percentage we want, so we need to find the z-score that would give this percentage. So let's go look at the table. As usual, the table will give us the probability up to a certain z-score. We want to know when we have 1% above the z-score. So we'll look for 99% in the table. This point here is closest to 99%. That's a z-score of 2.33. Now, if we can solve this for n, we'll find n, the number of tickets that can be sold, such that less than 1% of the time we get more than 350 passengers showing up. So it looks like we'll have to square both sides. Okay, we have a quadratic equation in terms of n, so let's get everything on one side. And we'll find the solution using the quadratic formula. So we get a value of 358.3. We'll round that to 358. Now, if we check the other solution, we get 379 for rounding. Now, one of these is a false solution, and that would be the 379. Notice how if we put it into the z-score formula, times it by 0.95n, that we'd get a negative in the numerator. So that's the one that doesn't make sense in this context. So we will throw that one out. So the answer is 358 tickets. That's the maximum they can sell, so that they'd have a 1% chance or less of more than 350 passengers actually showing up for their flights. Okay, that's the end of the test. Thanks for watching. I hope that it was helpful for you. Make sure you like and subscribe. We'll be putting more content out for HSC students, including more work solutions. If you have any questions about anything that was worked out, feel free to leave a comment. Good luck on your exams and have fun studying!